Hello everyone and welcome to Brain Blitz Audios. Today we will be looking at another episode of CAT curriculum where we solve previous year questions of the CAT examination. Today we are looking at some questions from the module of CAT that is Quantitative Aptitude, which is also shortened as QA. Now let's look at a couple of questions from QA in this episode. Here's our first question. The number of distinct real values of x satisfying the equation maximum of x, 2 minus minimum of the set x, 2 equals modulus of x plus 2 minus modulus of x minus 2 is. So this here is the equation. Now let's write it down again. Maximum of the set x, 2 minus minimum of the set x, 2 is equal to mod of x plus 2 minus mod of x minus 2. So we're dealing with two separate types of functions. The first function is the maximum minimum function. So basically over here, inside the curly brackets you have a set, and in case of the maximum function it's asking us to write down the maximum value that is present inside that function. Similarly, for the minimum function you're asked to write down the minimum value which is inside that particular function. So in this particular set we have x, 2 for both these functions, and so based on their place in the number line we need to find out which of these values, x or 2, is expressed. Now on the right hand side we have two modulus functions. Basically both of these functions integrate a modulus, and so when you have a modulus function in the form of mod of x, it basically gives you two values. It gives you x if positive, and it gives you negative x if negative. Now the idea here is to make sure that the values of x are all positive for any value of x. So if you have, say, mod of -1, then the value would be minus of -1, which is equal to 1. So basically in the modulus function we're giving you the numerical value without any sign. So basically the numerical value with a positive sign. So now that we've understood both these functions, let's look at the right hand side. The right hand side is mod of x plus 2 minus mod of x minus 2. Now in case of x plus 2, if we equate it to 0, then x equals minus 2. Now this point, minus 2, is what we call an inflection point. Now this is the same point where the value of the modulus changes from positive to negative. So where x becomes minus x, where minus x replaces x as the value of the modulus function. So for mod of x plus 2, the inflection point is minus 2, and similarly for mod of x minus 2, we will equate it to 0, so x equals plus 2. So therefore that is the second inflection point. So if you were to draw a number line, we would have three separate cases. The first case is when the value of x is less than minus 2, and the second case is where the value of x is between minus 2 and 2, and the third case is where the value of x is greater than 2. So let's check for each of these cases whether we get a distinct real value for the variable x. So in terms of case 1, this is where the value of x is less than or equal to minus 2. So remember, our function is maximum of x comma 2 minus minimum of the set x comma 2 equals mod of x plus 2 minus mod of x minus 2. Now, in this scenario where x is less than or equal to minus 2, the maximum function of the set x comma 2 will be equal to 2. Since we know that x has a value which is less than negative 2, so irrespective of what value of x there is, the maximum value in the set is 2. And similarly, the minimum in the set x comma 2 will always be x, since x is always less than minus 2, which is obviously less than 2. Now, when we look at the modulus functions present on the right-hand side, mod of x plus 2 has the inflection point at minus 2. So for any value of x below minus 2, mod of x plus 2 is negative, which means we get minus of x plus 2. Similarly, for mod of x minus 2, its inflection point is positive 2. So therefore, for any x less than minus 2, it's still negative, which means the value here would be minus of x minus 2. Now let's write down the equation here. So maximum of x comma 2 is 2 minus minimum of x comma 2 is x, and that is equal to, in case of mod x plus 2, the modulus is negative, so therefore we would get minus of x plus 2, which we can write as minus x minus 2, and then there's a minus since we're basically subtracting the two moduli. Now for the modulus function x minus 2, it's also negative, so the value here would be minus of x minus 2. Now this is equal to minus x plus 2, or 2 minus x. So this negative sign gets multiplied to both the terms in the bracket, so we get minus x minus 2 plus x. Minus x and x cancels each other to get 0, and minus 2 gives you minus 4. So 2 minus x equals minus 4. Basically, what we can do is take x minus x to the right-hand side and minus 4 to the left-hand side. So basically what we get is 2 plus 4 equals x, or x equals 6. Now here's the problem. In case 1, we have defined that x is always going to be less than or equal to minus 2. However, using that condition and applying that condition to the functions we have, we got x is equal to 6. But 6 is not less than or equal to minus 2. So this particular value of x is wrong. There is no real value. So there isn't a distinct real value of x. Now let's move on to case 2. In case 2, we have minus 2 less than or equal to x, less than x, which is less than or equal to 2. So basically we're between the two inflection points here. What we're going to do is define these functions again. So for the maximum function for the set x comma 2, the maximum is still 2, and then for the minimum of x comma 2, it's going to be x. Now in order for this to work, we would have to be very careful and make sure that this case is defined as minus 2 less than x less than 2, because that's when the minimum function will always be x. So this is how the case should be instead of using less than or equal to. Now if we look at the modulus functions, for x plus 2, mod x plus 2 that is, the function is now positive, so the value is now x plus 2 without a minus sign. However, mod of x minus 2 still remains negative because its inflection point is plus 2. So therefore, it still becomes minus of x minus 2, which is 2 minus x. So let's rewrite the equation here. So the maximum function is 2. The minimum function is x, so it's minus of x. On the right-hand side, we have mod of x plus 2 is positive, so that's x plus 2. Mod of x minus 2 is negative, so minus of 2 minus x, which means we get 2 minus x on the left-hand side, and on the right-hand side, we get x plus 2 minus 2 plus x, which means 2 minus x on the left-hand side equals, plus 2 and minus 2 cancels each other out. There are x plus x equals 2x. So 2 minus x equals 2x, which means 2 equals 3x, which means x is equal to 2 over 3. Now this here is a distinctive value, so the solution is valid. First of all, it's a real term. First of all, it's a real value. And second of all, 2 by 3 does lie between minus 2 and 2. So therefore, this solution here is valid. Now for case 3. In case 3, x is greater than or equal to 2. So in this particular case, the maximum value of x comma 2 becomes x, and the minimum of x comma 2 becomes 2. Now, since 2 is the inflection point of mod of x minus 2, both of our functions, mod of x plus 2 and mod of x minus 2, are both positive. So therefore, they'll be expressed as x plus 2 and x minus 2 respectively. So what we get as the equation will be x minus 2 equals x plus 2 minus of x minus 2, which is equal to x plus 2 minus x plus 2. So x minus 2 equals 4, which means x equals to 4 plus 2, that is equal to 6. So again, 6 is greater than 2, so therefore this solution is valid. So 2 by 3 as a solution for x is valid. 6 as a solution for x is valid for case 3. However, it is not valid for case 1, where x has to be less than or equal to minus 2. So since we have 6 as a valid solution and 2 by 3 as a valid solution for the second and third cases, this means that the number of distinct real values of x satisfying the equation is 2. So in the final answer, in the CAT exam, you would have to type in 2 as your answer. Now let's look at the second question for today. The sum of all the distinct real values of x that satisfy the following equation, 10 to the power x plus 4 by 10 to the power x equals 81 over 2 is. Now, all of the options are given in logarithms. 2 log 2 to the base 10, 4 of log 2 to the base 10, log of 2 to the base 10, 3 of log 2 to the base 10. So basically, the answer has to be expressed in log of 2 to the base 10. So how do we solve this question? Well, our original equation is 10 to the power x plus 4 upon 10 to the power x equals 81 over 2. So from here on out, what we're going to do is we're going to consider 10 to the power x as a, which is a variable. So by plugging in the value of 10 to the power x as a, we get a plus 4 upon a equals 81 upon 2. So in order to remove a in the denominator, we're going to multiply both sides by a. So what we get is a quadratic equation of the form a squared plus 4, because it's in this particular term that we have to cancel out the a in the denominator. So the equation would be a squared plus 4 equals 81 over 2a. Now we can rewrite that as, let's go back, we can rewrite that as a squared minus 81 over 2a plus 4 equals 0. So this is of the form ax squared plus bx plus c equals 0. So in a quadratic equation of the form ax squared plus bx plus c equals 0, we know that the sum of the roots is equal to minus of b over a, and the product of the roots is equal to c over a. So we're going to use the product of the roots formula here, and if we look back at the equation we got a squared plus 81 by 2a plus 4 equals 0. So we're going to consider a1 and a2 to be the two distinct roots of the equation. Now the value of a1 will be equal to 10 to the power of x1, and the value of a2 will be equal to 10 to the power of x2. And that is because we considered a as 10 to the power of x. So since we have two distinct roots, a1 and a2, their values will be equal to 10 to the power x1 and 10 to the power x2, where the indices of both these terms are distinct. So we're going to use the product of the roots rule here. So a1 multiplied by a2 is equal to 10 to the power x1 multiplied by 10 to the power x2, and the value of that is equal to 4 upon 1, which is 4. Now why 4 upon 1? 4 is the constant term. Divide that by the coefficient of a squared, which is 1. So what we get is 10 to the power x1 multiplied by 10 to the power x2 equals 4. Now this particular part, that's 10 to the power x1 multiplied by 10 to the power x2, we're going to use the product rule of exponents. Now that is a to the power x multiplied by a to the power y equals a to the power x plus y. So the exponents get added. So therefore our equation now becomes 10 to the power x1 plus x2 equals 4. Now what we're going to do is we're going to convert this into a logarithm, and the reason being our answers are all expressed as logarithms. So therefore we're going to consider this as a to the power b equals c, and so the logarithm of this would be b, that is the exponent, will be equal to log of c, that is the answer, to the base a. So by using that, we will get x1 plus x2 equals log of 4 to the base 10. Now what we're now going to do is, since if you look at the options, you can see that all of them have the number 2 right after the logarithm. So it's all expressed as log 2 to the base 10, whether it's twice that, 4 times that, 3 times that, or 1 times that. So basically every answer is expressed in the form log 2 to the base 10. However, right now the logarithm that we got is log of 4 to the base 10. So we're going to use the formula log of x to the power a equals a multiplied by log of x. So 4 will be considered as 2 squared. So therefore, x1 plus x2 equals log 2 squared to the base 10, which is equal to 2 times log 2 to the base 10. So the answer that we got for the sum of all distinct real values of x is 2 log 2 to the base 10, which of course is equal to option A. So option A turns out to be the right option. All the other options are incorrect because the coefficient 2 log 2 to the base 10 is incorrect in the other options. So option A, 2 log 2 to the base 10 is the right option. So if you have x in the exponent and you need to find the sum of that, then the best way to do that is to convert this into a quadratic equation using another variable, and then use the laws of exponents as well as the laws of logarithms in order to get your answer in logarithms. So option A, 2 log 2 to the base 10, turns out to be the right answer. Now that concludes this particular episode of CAT Curriculum. We hope you found this episode interesting and informative. For more of our useful and interesting content, don't forget to subscribe to our channel, Brain Blitz Audios. If you want to learn more about the CAT examination or on other competitive examinations, please don't forget to check out our latest videos in our channel. You can also hit the notifications icon to receive messages about our latest uploads. So until the next video, take care, stay safe, ta-ta for now.